And so, example, so given, I don't think I did this guy right. Given sine theta equal to square root 3 over 4, find the 6 trig functions. So, using this trig function, we'll build a triangle, the right triangle, and then just find the sine, cosine, etc. using the definitions, right? So we know that sine theta is equal to the opposite over the hypotenuse, right? Cosine theta is equal to adjacent over hypotenuse. And tangent theta is opposite over adjacent. Okay. What is cosecant? And secant and cotangent.
Cosecant is hypotenuse over opposite.
Yeah. And secant?
Hypotenuse over adjacent.
Cotangent.
Adjacent over opposite.
So we have all the stuff we need now, right? We just have to build the triangle and fill in the blanks. So, all right, let's build a triangle. Now, when we say opposite, adjacent, all that garbage, what we're referring to is where the angle is. So if I put the angle here or up top, the definition of opposite would be different, right? Like for example, if I put, I don't know, beta up here, cosine or sine of beta would be opposite, right, over hypotenuse, because it'd be opposite to this angle. Sine of theta would be opposite over here. You see what I'm saying? So it all depends on the orientation, and in this case, we're deciding where the angle is. Right? Of course, we cannot decide this guy because that's a right angle. That's already given. But you see what I'm saying? When we say opposite, we mean to the angle we're talking about. Here we're talking about theta. So the opposite would be root 3 over 4, right? Hypotenuse. Use Pythagorean theorem to find the missing side. So I know that a squared plus b squared equals c squared. So that would be, what? We'll solve for b, I guess. We'll say that a is root 3, and I want to know what b is. C is c squared. Sorry, right there, 4. So I'm going to subtract this guy over there, and then square root both sides to solve for b. So I'm skipping a minor step here. Is that okay? So then b would be the square root of this stuff. Which is the square root of 16 minus 9, or sorry, 3, right? Which is square root of 13. Anyway, I know for a lot of you, we don't have to go through this part, but just in case there's some confusion, there it is. You guys comfortable with Pythagorean theorem? Once we have all the sides, we can build the triangle, right? Okay, so, or sorry, we can find, once we build the triangle, we can find the functions. So sine is already given to us, right? That's going to be root 3 over 4. Yeah, I don't like the way that looks. I'm going to rewrite this. So sine theta is equal to square root 3 over 4. Cosine theta is equal to adjacent over hypotenuse. So what's going to be cosine?
Square root of 13.
Yeah, root 13 over what?
4.
4. Okay. And then finally, tangent will be opposite over adjacent, right? Okay, so those are the first three. This one was given, which helps us find the rest. Now, cosecant theta is just simply 4 over root 3, right? This is my scratch work. See? But they might rationalize this. So technically that would become, do you remember how to rationalize? No, we don't like square roots on the bottom. That's what they told us in algebra. So we kind of have to force a square to happen by multiplying the top and the bottom by root 3. So that becomes 4 root 3 over 3, which is the same as this. So they might want this guy in the homework, or they might take this one. I don't know. You'll find out, I suppose. Or they might tell you. Cosine, secant. So now we need secant. Secant theta is going to be 4 over root 13, which can be rationalized as 4 root 13 over 13. Cotangent will simply be root 13 over root 3. I know we got a little messy here, but do you have any questions on this?
Are we supposed to take the square root of 3 out of the out of the cotangent?
We can. We usually should. If we multiply top and bottom, we'll end up with, I don't have any space. I'm going to move this triangle. Technically, we should. I don't know if the homework will take either one. If they specify, well, great. All right, so we had an opposite of root 3, hypotenuse of 4, side of adjacent side of root 13. Okay. Yeah, if we rationalize this, this would become square root 26 over 3. I skipped the rationalization step. Guys have any question on the Pythagorean theorem part, the definitions, or the rationalization? Does it make sense?
Makes sense. Mm-hmm.
Okay. All right, so in the homework, you also have stuff, they use a complementary angle theorem. So I'm going to go ahead and give that to you, and then we'll do a couple examples. So for the next few questions, it's going to say use fundamental identities or complementary angle theorem. So use fundamental identities and or complementary theorem. Complementary theorem is this here. Complementary theorem is when sine theta is equal to cosine of 90 degrees minus some angle. Cosine theta is equal to sine of 90 minus theta. So you can shift back by just subtracting whatever angle is in here from 90. You can change it. Okay. We may also need the Pythagorean theorem, or Pythagorean identities we did. All right, so first example using these ideas, cosine 86 degrees over sine of 4 degrees. You see how these are complementary, right? 86 and 4. The sum of the angles equals 90, which makes them complementary, right? So that means I can shift and cancel, right? So the bottom I can change into a cosine if I just do this, cosine of 90 minus whatever angle I was given, which would give us the same thing, right? You see what I'm saying? So use a complementary theorem to just cancel. So the answer would simply be a 1.
This might be a weird question, but what does that 1 mean? Like, what does it stand for?
It's literally like, I guess you could think of it as this is just a weird way to write the number 1.
Okay.
It's kind of like when you divide into something and it all cancels out.
Yeah.
When it cancels, you're left with 1. Like 4 divided by 4 turns into a 1. So this is showing us that this is actually the same thing by using the complementary theorem.
So it's like the same distance around, circumvented, or whatever that word was.
Yeah. So since so if you have complementary angles that sum to 90, you can always shift back and forward. So you can shift anytime you want if you have a number. But when you see this stuff like that, you see something that adds up to 90, then that's like a hint that, well, maybe I can do something.
Cool.
Yeah. Let's do a different one. So 1 minus cosine squared of 38 degrees minus, let's see here, cosine squared of 52 degrees. So you see the angles sum up to 90, right? So if we shift it to sine or cosine, either way, we may be able to do something that helps us out. So what we can do is change this guy into a sine. So I'm going to change it into sine squared of 52 degrees minus cosine squared of 52. So from here to here I use the idea that cosine squared of 38 is equal to sine squared of 90 minus 38 using the complementary theorem. That's what we did. So I replaced this, substitute. But the reason we did that is so you can see this. I can factor, right, a negative out, giving us sine squared of 52 plus cosine squared of 52. So sine squared plus cosine squared is just 1, right? So this right here, we have to remember, it's one of the original identity we talked about last time. So for any angle theta, if they are the same, sine and cosine squared, when you add them together, will always equal to 1 for any theta. So that's what we have inside, right? So from here to here, we're going to use that theorem, or that identity, I guess. Be 1 minus 1, right? All this is 1. That's inside the parentheses, technically. So then that will be 0. Okay. Is there any steps that don't make sense? I'm going to go see what's wrong with that dog. Is this question okay?
So for this setup, this could also work for like tangent and cotangent.
The complement?
Yes.
For tangent and cotangent, there might be a different. I know for sure sine and cosine, because they're pairs. Let me double check before I say no. I want to say no, but I like to back it up first. One moment. You could, think about it. If you have a tangent, you could break it into sine over cosine because it's tangent is just a ratio of those two functions, right? So, so the answer would be yes if you convert it to sine over cosine. If you want to use like the complement property.
So, okay, so how you have the top two lines connected together. Yes, please. Okay, so you have those two top lines together with that on the side, right?
Yeah, so I made a note that I did this to get from there to there.
Okay, so that's what I was gonna ask. Is it actually part of the equation or it's like a note?
No, this is just a note. This is nothing. Nobody erase it. Is that weird?
No, I just because I'm not good at this stuff. So I just need to make sure that I
Yeah,
can
so-
follow this step by step.
So I added extra steps to you, so when you read this later, you see what happened. So from step 1, the original question, to here, I replaced cosine squared with sine squared, right? But what did I use? Well, I used the complementary theorem, and this is what I left out. So cosine squared of 38 degrees is equal to sine squared of 90 degrees minus 38, which gives you sine squared of 52. So that's where this came from.
Okay.
Because the book will just go jump to here, right? They won't show anything. So I was like, you know what? Let me write down the property that I used here. Then the next step, you factor the negative out. So they both become plus. So sine squared plus cosine squared is always going to be 1. So this inside became a 1. So 1 minus 1 is 0. So the whole point of all this was to simplify the problem using your Pythagorean identities, complementary theorem, and possibly ratios of sine and cosine and tangent. Those I'll remember all those properties I made you write last time. I would have those handy while you do homework.
Right.
Okay.
Thank you.
Does that make sense, or does that answer your question?
Yes, it answers my question.
Okay. Any other questions? You guys okay? All right. Let's keep going then. Oh, here it is. All right, so let's move on to 7.3.
Before we move on, can I ask a question?
Yeah.
So, how did you get -1?
So you see it on step 2 here, or the first step. They're both negative, right? So factor the negative out. In front, we'll put parentheses and make everything inside positive because you factored the negative out, right? So this negative is right there the entire time. So it's factored and it's waiting for you, right? Does that make sense?
So how do you get the 1?
This one?
No, the one in the parentheses.
That's the theorem. It's a property. Whenever you square sine and cosine, if it's the same angle, it will always be 1. That was from last time. You remember one part of the identities I made you write down, or I sent you. So this is the Pythagorean identity. Sine squared theta plus cosine squared theta is 1. So see how they're both the same angle right here? So that satisfies a requirement. They're both squared. They're both positive. Same angle. Then that means it has to be 1.
Okay, understood.
I guess real quick before we do move on to 7.3.
Sure.
So like in the homework,
Mhm.
I was having a lot of trouble. I mean, I know we didn't finish all of 7.2, but they still have it set it up in the homework where one of the questions was sec 40 degrees equals cosec blank degrees. I had no idea how to solve that.
Secant, what was it?
40 degrees
Mm-hmm.
equals, I guess cosecant CSC blank degrees.
So it's written like this.
Right. And I have no idea how to, like, where do I begin?
What you said that was 7.2. Let me double check everything before we start. 7.2. Question. Oh, here it is. Okay. Do you remember what number that was?
For me, it was number 3.
Let me see. Yeah, it looks like it's going to be a complement kind of thing. Yeah, it comes from the complementary theorem. So basically, how would you make these equal? And what is the number that needs to go in here to make it equal? Like, well, let's change them into what they're supposed to be. Secant as a reciprocal is the same as 1 over cosine, right? I think this will make more sense if we do it this way. Cosecant is the same as 1 over sine, right? I don't know what that angle is. So doing what we just did, let me see if I'm still on the right spot. Yeah, there it is. How do I change this into a sine, right? Complementary angle says I can just take 90 and subtract whatever angle I was given and change it to cosine, right? And vice versa. So what you do, so you know what? If I want to change this into, if I want to make these equal, changing this side would be 1 over sine of 30. No, I'm sorry, 50. Let me show the work though. Formula says sine of 90 minus 40. Which would be 1 over sine of 50. So basically what they're saying is, using the complementary angle, how do I make this to be equal? Well, you would have to shift it, or in other words, this would have to be a 50 to do a complement. But I think actually changing it into this, showing that they're equal, right, makes a little bit more sense. So use a complementary angle to change the side that does have a number to match the other side. But just by looking at it, you can say, yeah, okay, since these are both sine and cosine, technically, and this is 40, well, this has to be 50. That's the only way they'll add up to 90.
Oh, so just trying to make them equal to 90.
Right.
Oh my gosh.
Yeah,
Okay.
so that's the only way they'd be equal is because of this idea. So they're using this in the background. But see how it has to be some sort of complement of 90.
Yes.
So that's why this has to be 50.
Thank you. Now, I don't know. Now it makes sense to me. Thank you.
Okay. Yeah, sure. Okay, you guys have any other questions on 7.2? I'm going to look through it and write real quick while I wait.
That property that we're talking about, right now when you were explaining this particular problem, you got secant 40 degrees, and then we had the question of it equals cosecant of, we're trying to figure out the angle, right?
Mm-hmm.
And you, your words were, we got to change it to the right one or to the right thing. But what I'm getting at is like, these properties between the angles. You changed secant to cosine. I mean, like what I'm trying to say is like, I mean, it looks like it's the same. Like we understand secant is, I guess, the opposite of cosecant, right? Is that right?
So secant is a reciprocal of cosine, right?
Cosine, okay.
And cosecant is a reciprocal of sine.
Gotcha.
So once
Okay.
you see this, then that gives you like the idea, like, oh, these are complements. It has to be 50, otherwise it wouldn't be equal.
Okay. I see what you're saying now. I see what you're saying entirely. Yeah, that makes sense. I was looking at the wrong. No, I got it now. I'm good. Thank you very much.
Yeah, that's fine. Yeah, on the first line, we can't straight up say it unless you know that these are cosine and sine. That's why I show this extra step. Because right here, the formula tells us, yeah, we're good.
Gotcha. Yeah. Okay. That makes sense. Okay, so that's the reciprocal and that equals that. Okay. Yeah, and that's the reciprocal of sine. Okay. Cool.
Yeah.
All
Guys
right.
have
Thank you very much.
guys have any more questions on 7.2? Okay. Move on to 7.3. Let's take a short break, and we'll hit 7.3. It's 7:46, 47. I guess come back at 7 o'clock. All right, let's get to it. So here, let me get my PDF file in case you don't have it. Space for a month. I think 90% of this homework looks like we're just going to be using this to help us out. Okay, so make sure this is open somewhere. I'll keep referring to it. Okay. So, first example. Compute the values of the trig functions. All right, so first one, sine of 60 degrees. Well, so literally, we'll look at your circle. What would that be? So the homework starts off pretty chill. All right, so 60. We just need to know like what is sine and what is cosine. So when they ask for sine of 60, that's the same as asking for sine of pi thirds. Sine refers to the y value. Okay, so sine of 60 is the square root 3 over 2, which is this number right here. If they were to have asked cosine of 60, that would be the 1/2. Okay, does that make sense? How you read the circle? So cosine is the x part, sine is the y part. I'm going to write that down right now. Okay, so cosine theta is equal to the x value on the unit circle. Assuming they picked a nice theta. Sine theta is equal to the y value on your circle. Is there any questions on this idea here? Okay, so then they'll make it a little bit harder, but it's really the same deal. They'll just add some numbers like this. Let's say 4 cosine of 30 degrees minus 6 sine of 30 degrees. So looking at your circle, what is cosine 30? The 4 will stay there, so I'm going to just put parentheses. Let's look at our circle.
Remember the 3 over 2?
Yeah, I think you're right. So cosine 30, the x value is this one. Yeah. So square root 3 over 2 is replacing the cosine. 6. Now sine 30. It's going to be the y value, right? So that will be half. Let me switch back over here and make a note. From here to here, we used the unit circle. And those values are actually, I'm not going to make you do it, but the way they're derived, right, is they use Pythagorean theorem at every single angle to try to solve for these pieces. Okay, assuming that the radius is 1. But if you have the circle, you should be fine. You don't have to actually do the derivation. Okay. Any questions on that first one or that second problem? Oh, I guess we should solve that, huh? Just for fun. So 4 times square root 3 over 2. That's the same as saying 4 over 2 times square root of 3 minus 6 over 2 times 1. Is that weird? Right, because you can, in other words, you can reduce the fraction by canceling these guys, which will leave you with a 2. Cancel these fractions, leaving you with a 3. Right, this is a 3. All right, so that would be 2 root 3 minus 3. But anyway, let me make this look a little prettier. I don't like how messy that got. I assume you guys are comfortable with fractions or no? A little bit.
Dislike, but comfortable.
Okay. So just reduce these fractions and you will end up here. That's all we did. Does you guys have any question on how we got there? Okay.
How do you know when you're done simplifying it?
If you can't factor anything, if you can't reduce anything, there's no more fractions. You can't combine these. These are not. What's the word? See how this is a 2 square root 3? In order to combine them, this would also have to be a square root. So this is exact, and that's as far as you can go. The next step is calculator approximation, the decimal. But most likely I want a exact answer, so you can use this guy. But technically, if you were to have this 2 root 3 plus 4 root 3, then you could combine them into 6 root 3. So I have 2 of them plus 4 more, I have 6 of them. But here they are not the same. They are not like terms, I guess is the best way to phrase it. Okay. Secant of pi over 4 plus 13 cosecant of pi over 6. So here it would be easier to change these into the reciprocal, right? Because what is secant? It's 1 over what?
Secant. Cosine?
Yeah, it's going to be cosine of pi over 4.
And that's sine, right?
Yeah, sine, right. And there we go. Okay, so now let's look at our circle and we can start simplifying. So cosine of pi over 4 is square root 2 over 2. So I'm going to write that right here, then I'll switch over. Sine of pi over 6 is 1/2, right? Okay. So what do you do when you have fractions down here? Yeah, just flip the bottom or take the reciprocal and multiply, right? So this would be 2 over root 2 plus 2 over 1 times 13. So that would be 2, I said, not 3. Root 2 plus 16 over 1. Sorry.
26?
Why is that six? Why is that
26?
16?
Yeah, sorry, 26. I don't know why I put 16. 2 times 13 is 26, right? Okay, so at this point it's technically done, but here we have a screw at the bottom. So you would rationalize that to get to 2 root 2 over 2, which would cancel this. But anyway, this is just algebra step. Do you have any questions on the pre-cal step, the fractional step, or the algebra steps?
What does that say at the bottom? When you try to,
Here?
simplify it? So you did that equals 2 square root 2 over what?
Go to this step here.
Right.
Here, let me. So this is 2 over square root 2 plus 26 over 1. So if you rationalize the first piece, you're going to get this. You want me to show you where this came from?
Yes.
Let's do that, just to be clear. Okay, so to rationalize, remember we said you have to basically square the bottom, but the only way to do so is to multiply by the same thing on top and bottom. So that will square the denominator. The 26, I'm not going to do anything. It's just there. So 2 times root 2 gives us 2 root 2. Root 2 times root 2 gives me root 4, which is 2. So when you multiply something times itself, it gets squared and cancels the square root. That's how we got to here. Do you see this step here from here to here?
Yes.
So then at that point, these 2's will cancel, right?
Mhm.
So at that point, we're left with root 2 plus 26. And there's this. That's as far as we can go.
Okay. Thank you.
Remember, don't forget that secant theta is equal to 1 over cosine. That's what we used here. Cosecant theta is equal to 1 over sine. It's a side note for how that happened.
And that's just another way of writing like that's the reciprocal of cosine and that's the reciprocal of sine, right? Or cosecant, right?
Right, right.
Okay.
Because technically you could say cosine is equal to 1 over secant, right? And sine is equal to 1 over cosecant. But yeah, this is the reciprocal property we talked about. Any questions on this example before I move on to something else? Okay. Do you guys remember your composite functions in college algebra? The f of g and g of f. Do you remember that? Fog.
No.
Yes.
All right, let's go over a little bit just in case. So they first introduced this notation when they had a sum of functions. So f plus g, it's an ugly g, but of x is the same as saying f of x plus g of x. You remember that? And then they had f composed with g of x, which means f of g of x. That was what the notation meant, meaning you're putting the g function inside the f function to create a new function, a composite. And the other direction, g of f of x is equal to g of f of x. Does that look familiar a little bit?
A little.
So just a little side note here. So if your f was, let's say, x plus 3, and your g was x squared, f of g would be you plugging in the g inside the f. So it would be like this. F of g of x, which would actually be just f of x squared, which meant you put in an x squared wherever you have an x. So we have an x there. So you would get x squared plus 3. That's how you would make them. Okay. Just a quick review from college algebra. Okay. So this question assumes you remember this. So let's see how it goes, right? Sorry, I got distracted. F of x is equal to sine g of x is equal to cosine. So they say find the value of f plus g of 60 degrees. So this notation simply means you add them together, right? So this is really saying, let's write the notation. F plus g of 60 means f of 60 plus g of 60. But f is actually sine, right? So sine of 60 plus cosine of 60, which is equal to, what is sine of 60?
Goes 40.
That is true.
Goes
Well,
on 40.
well, actually, third, it would be 30, right? But I see where your head's at. But the value, all we gotta do is just use a circle. So sine of 60 would be this guy, right? So root 3 over 2 plus 1/2. So add them together. That would simply be square root of 3 plus 1 over 2. There we go. Is there any questions about, because honestly, this is not too bad, right? It's just, yeah, remember, make sure you know the notation. So if you know the notation, then it's not a big deal.
Why wouldn't the denominator be 4?
Because when you add fractions, you only add the top part if the bottom is the same.
Oh, okay.
Like if you have a quarter, right?
Could you go back? Sorry, could you go back to sharing your?
Oh yeah, sorry.
Thank you very much.
Yeah, so a quarter plus a quarter is 2/4, right? Which is a half. So we always add the top if it's the same. So don't forget. You only do the top and bottom if it's multiplication.
You said to know the notation. What's the notation?
Oh, this here. When they write something like this, f of g60, you need to know that you're separating it.
Okay.
And once you've separated, then you should know what is f and g. Well, they told you at the beginning.
Okay.
So you just put them in here.
Gotcha.
Okay. All right, so here's a composite type. So let f of x equal cosecant x and h of x equals 2x. So they have an f and an h, and then they say, okay, find f of h of pi over 6. So that means, right, using the notation I showed you, it means f of h at pi over 6. So you can write it more clearly and say, well, h is 2x, so that would simply be f of 2 times pi over 6, right? Because I'm plugging that in here, right? 2 times pi over 6 is pi thirds, so we're really doing f of pi thirds. Cosecant of pi over 3.
Sorry.
No,
I
you're
might
fine.
got-
What's up? Do you have a question, or I don't know if I heard you right?
So you just divided the 2 and the 6 to get pi over 3.
Yeah, so 2 over 1 times pi over 6 is what's happening, right? So that's the same as saying 2 pi over 6, which would reduce because you have a 2 and a 2 down here. 2 times 3 is 6, so these would cancel. So we're really just reducing a fraction. That's what happened here to here.
Okay, I guess like I said earlier, I am not good at this at all. Like, could you not skip steps?
No, yeah, I will try not
please,
to.
like, don't assume that we know where the numbers came from, I guess is what I'm asking.
I won't. I will ask you every single time if there's anything that doesn't make sense. But I am showing extra steps, and I will.
Okay.
But this
Because
guy.
then when I see them, when I see them off to the side, I don't know, it's like kind of hard to remember like where it came from. So if it's like a part of the equation, it helps rather than them just being thrown off to the side. Does that make sense?
Sure. Yeah. No, I will keep adding extra steps, but I can't keep doing the fraction steps all the time. But I will if you need it, or if you don't see it, or if I forget something. It's not a big deal. But
okay,
at a certain point, I need you to get more comfortable. But right now, let's show it because I agree with you.
As far as the
Mm-hmm.
two filling in for the H, how does that come about again?
So H is equal to 2x, right? So H of pi over 6 means I'm plugging it in here, right? The notation from the functional notation.
Mhm.
So for you remember it, if I said H of 0, that means you plug in 0, right?
Right.
So H of pi 6 means I plug it in here. So that's where this 2 times that came from.
Oh, okay. All right. I bet. Thanks.
No, it's okay. So at this point, we have the fraction. So reduce it. So remember, this will reduce, giving you a 3. So now we have f of pi over 3. Okay. So is all the steps clear, or is there anything weird? You guys still with me?
That makes sense.
Okay. So just plug it in. At this point, this means, right, cosecant of pi thirds. What is cosecant?
Another sign.
And sine of 1 of pi thirds?
Square root of 3 over 2.
Square root of 3 over 2, right?
Mhm.
Now that at this point, you just take the reciprocal because it's at the bottom. So fraction rule says you flip it over and you get to here. Okay. At that point, you can rationalize, but it really depends on what they want. But to rationalize, you'd have to multiply the top and bottom by root 3. This gives you 2 root 3 over 3. Okay, so this is the rationalization step. This is just a fraction being flipped over because of the reciprocal. Dividing by a fraction always does this. And this is the definition of cosecant. And all this is the college algebra stuff about composite functions. Is there any step that is not clear, or if you need some extra step somewhere, or if
I
I
have
don't
a
make
question on this step.
uh-huh.
So on the, I believe it's the second step when you're gonna multiply 2 and pi over 6. Could you explain how you got that answer?
Where? I'm sorry, one more time.
It was 2 pi time or 2 times pi over 6.
Yeah, so yeah, that's what I was showing over here. Remember, I had 2 over 1 times pi over 6. Right. So how do you reduce this? What happens? You end up we can go ahead and multiply if you want, but you should see that there's a common factor of 2. So it will reduce into a 3. Right, that's what's happening here.
Okay, that makes sense.
Yeah, I mean, don't let the pi bother you. I mean, it's just pretend it's a 2 6, right? What would you do? It's 2 over 6. See what I mean?
Yep.
Okay. Ready? All right, 1 second. let's do a couple of word problems and then we'll move on to 7-4. Okay. So a right triangle has a hypotenuse of length 4 inches. If one angle is 44 degrees, find the length of each leg. So sometimes these word problems give you a picture. I don't remember if this one did, but I'll draw one for you. All right. So they gave us one angle. They said it's going to be 44 degrees, right? So I'm going to put that guy here. And they said the hypotenuse is 4 inches. Can you find the other two legs with only that information?
Yes, you can.
Yeah, right. So let's
Yeah,
use
you would
the.
use.
Yeah, what would you use?
You could use sine or cosine for this one.
Yeah, I think sine. Yeah, either one would be fine. Let's do sine, I guess. Sine of 44 degrees is equal to the opposite side, which we'll call, I don't know, opposite, over hypotenuse, right? So how would you solve for that missing piece?
You're going to multiply 4 by sine 44 degrees.
You guys multiply both sides by 4, right? So 4 times this side, 4 times this side. That will cancel this guy. So now, what is 4 sine 44?
$176.
I don't know.
Or
Where's my calculator at? 44 is not an angle on the unit circle, so we'll have to use the calculator.
also in the calculator, type in like 4 sine.
Yeah, and make sure you are in degrees.
Okay.
Depending on what kind of calculator you have, you change it to degree mode if it's not already. So 4 sine 44. That is the opposite side. So let's round to 1 decimal place. So 2.8 is the opposite side.
Okay.
Okay, so I'm going to put that right here.
When you can you please tell me how to get to degree mode on the calculator?
Do you have this one? Same one?
I have the TI-83.
Yeah, you should be able to just hit mode and then go down to where you see radians and degrees somewhere and change it.
Oh, okay. I see it. Thank you.
Okay. So once you have 2.8, you can use Pythagorean theorem to find the missing piece because the question is asking you to find both sides. right?
Yeah.
So a squared plus b squared is equal to 4 squared, right? So I'm going to put,
How do I get out of that mode now?
hit second and then mode.
Okay, thanks.
No, that's fine. So put 2.8 squared equal to 16. So at this point, subtract the 2.8 over. And then square root both sides. So a is whatever this is, just calculator time. Okay. So calculator says that this is approximately 2.9 inches. So 2.9 inches is the other leg of your triangle. Any steps that were weird or you didn't catch?
Is there a reason we don't square 2.8 before subtracting it from the other side? It's all the same thing, right?
Doesn't matter. You could square it first if you like.
Just wanted to make sure there wasn't something I wasn't missing about the square
No.
root.
I just want to do it all at once. That way I don't have to, because I'm squaring a decimal. Whenever I square weird numbers like this, especially square root them, I want to do all of it at once. That way I have more accuracy. Because if I square it and then round, stuff happens. What's up?
I'm sorry, do you mind going over that bottom part again? Because I was trying to figure out my calculator and I missed the bottom part, that a square plus b square equals 4 square.
Okay, so we use the Pythagorean theorem to solve for the missing leg. We found the first leg, 2.8, using the opposite over hypotenuse idea, right? So this is opposite over 4. So we just solved for the opposite. We got this. So now plug this guy into your Pythagorean theorem here. And then solve for A. That's all we did here is solve for A. Once you have A, that is the missing leg.
Okay, thank you.
And the bottom part, a equals square root 16 minus 2.8 squared. Is that like you just plug it in the calculator?
Yeah, that's why I put a little wavy equals, because it's approximately, and it's given by the calculator, so you got to round it.
Okay.
And any other questions? Is the algebra okay? I didn't show too many steps, but do you see how we solve for A?
Yes.
Okay. All right then. Okay. So the next one, it's another word problem. They say find the distance from A to C. So I guess try to draw. I can't draw worth a damn, but find the distance from A to C across a gorge. So here's the gorge. So there's the hole in the middle.
Jack, can you raise your paper up, please?
Yes, thank you. So picture just Grand Canyon or something, right? Something on the other side. You're over here. You have this distance from here to here is 90 feet. And you're able to find the angle from here to be, let's say, 40. So really what I want to know is how far is it from here to there. I know this picture sucks, but do you see what I'm trying to say? So all you have to do is find this side. So the application of solving for triangles can tell you distances. And you can find these angles by using those surveyor tools, right? You can just say, all right, the angle of elevation from here to there is 40, and then you can find all kinds of information. A lot of these ideas are used, or nowadays they're automatically using computers. Like if you were to, like if you're in Iraq and you were launching artillery, a lot of this stuff is already calculated, but sometimes it helps to know your angles, elevation, etc. And sometimes you can't measure this distance. There might be enemies over here shooting you, or it might be too huge of a gap that you need to figure the side out. Like, all right, how far away is this, right? So these ideas are used all the time. Same thing with triangulation on GPS. It's all triangles type of ideas. But anyway, all I need is this side. We'll call it X. What trig function should I use to help me find this?
I think it's cosine theta, which is adjacent over no, but you need to find the x, right?
Yeah, I need
You
the
can
X.
use you can use tangent.
Okay.
Yeah, tangent would be the one we want because it doesn't need the hypotenuse, right?
Okay.
The tangent of 40 is equal to adjacent over opposite. Oh, wait, I got it backwards. Opposite over adjacent. So tangent of 40 is equal to 90 over x. So let's just solve for x and we're done.
Wait, that's 90 over x, or
Yeah, this is 90.
X over 90, right?
Yeah, you're right. Sorry. I'm getting tired. Opposite is x. Opposite to the angle. Adjacent is right next to it. So just multiply 90 on the left and right, and we're good. So 90 times tangent, 90 times x over 90.
So when you say 90 is adjacent, you're saying that 90 is adjacent to that 40.
Right. That's what we mean when we say opposite adjacent. We mean in reference to that angle.
Okay.
So opposite tangent of 40 is opposite from that angle, x, over adjacent to that angle, 90. That's always going to be that way. So I was saying earlier, like if your angle is up here, then your opposite and adjacent will change, right? So what is x? Let me put some arrows here. X equals 90 tangent 40. So calculator time.
I think it's about 75.52 approximately.
Yeah, let's do this. Use this rounded to 75.52 sounds good. Feet. That's how far across this would be. Any questions on any of the steps? Okay. I don't have enough time to start another section. You guys have any homework problems you've been concerned about, or general questions? Seven, 4.
Oh, she's cute, Joshua.
Thank you.
No, Josh.
Some math, I think so.
All right, guys. If you have